In this video, I'm going to talk about spherical mirrors. There will be three parts to this video. Part 1 is about an overview of spherical mirrors. Spherical mirrors are of two types. First one is a concave mirror. The second one is a convex mirror. So I'm going to draw a concave mirror. Concave mirrors have reflective surface inside the spherical element. So this is the reflective surface. And this side or this surface is a hard surface. It's covered with something or painted so that light doesn't pass through. If light rays are coming parallel to the x-axis, a concave mirror would focus the light rays to its focal point F. So it's a converging mirror. Concave mirrors mostly form real and inverted images, sometimes magnified as well. So they can be used as dental mirrors or shaving mirrors. They can be used in reflecting telescopes as well. A convex mirror has a reflective surface outside of the spherical segment. So this is the reflective surface. This is the hard surface. Light rays coming parallel to the x-axis would reflect as if they diverge from a focal point behind the mirror. Convex mirrors produce erect and diminished images behind the mirror. So these are virtual images, but they have a larger field of view compared to the concave mirrors. So they can be used as rear view mirrors of vehicles. Now let's talk about geometry and points of spherical mirrors. I'm going to draw a concave mirror. If I extend this mirror, I would get a circle. There is a center for the circle. We call it center of curvature. Now I'm going to draw a line passing through the center of curvature and the mirror. If you have a Cartesian coordinate system, this is the x-axis, and we call it principal axis. The point where principal axis intersect with the mirror is called pole. You can use P or M to represent pole. You can also use M. The distance CP is the radius of the circle. So we call it radius of curvature. Midpoint of radius of curvature, or CP, is called focal point F. So this distance is the focal length. Focal length is always half of radius of curvature. F is equal to R by 2. Because F is at the midpoint of the radius of curvature, or CP. You can mark the same points for a convex mirror as well. But all these points would be behind the mirror, on the right hand side of the mirror. So I'll draw the principal axis. This is the center of curvature, C. This is the pole. And this is the focal point. Everything is behind the mirror. Now let's learn 4 rules that would help us draw the ray diagrams of concave mirrors and convex mirrors. We have a concave mirror here. This is the principal axis. This is the center of curvature. This is the focal point. And this is the pole. P or M. It's fine. Yeah. Light rays always come from the left-hand side. So if you have a light ray that comes parallel to the principal axis, so these two lines are parallel to each other, the reflected ray would pass through the focal point. So that's rule number 1. Now rule number 2 is just the opposite of this. If a light ray comes in through the focal point, the reflected ray would go parallel to the principal axis. That is rule number 2, just the opposite of the first rule. Now rule number 3, that's my incident ray. It's passing through the center of curvature. The reflected ray would go back through the same point. That's rule number 3. If an incoming ray passes through the center of curvature, after reflection to go back through the same point, through the center of curvature, it takes a 180-degree U-turn. Now the last rule is, if an incident light ray hits directly at the pole of the mirror, it would reflect off at the same angle. That's rule number 4. If this is theta I, this is theta R, reflected angle, theta I should be equal to theta R. That is rule number 4. So these are the 4 rules that we will apply when we draw the ray diagrams. I have explained it using a concave mirror, but you can also use convex mirror. So that's a convex mirror. This is the principal axis of the convex mirror. This is the center of curvature. This is the focal point, everything behind the mirror. This is the pole. A light rays always come from the left hand side. That's the conventional way of drawing it. If a light ray comes in parallel to the principal axis, after reflection, it would reflect off the mirror as if the reflected ray is coming from the focal point behind the mirror. Just like that. This is the second rule. Concave mirror. Incoming light ray after reflection should go parallel to the principal axis. That's rule number 2. Now rule number 3, principal axis, focal point, center of curvature. That's the incoming light ray. Yeah. Rule number 4, convex mirror, principal axis, focal point, center of curvature, and pole. Incoming light ray, yeah, it would reflect off at the same angle. That's rule number 4. These two angles are equal. So these are the 4 rules for concave mirrors and convex mirrors that we should consider when we draw ray diagrams in the next video.